You started it now.
Yes.
Okay. Hello. Welcome back to another Math Counts meeting. Today we are doing 2011 Nationals, and we are starting on sprint number one. Did you want to read or?
Yeah, I can read it. What is the sum of all the two-digit positive integers AB with the property that the units digit B is 4 times the 10th digit A? So,
Okay. So if the units digit is 4 times the tens digit, you know, digits are only
they're one
you
digit.
know,
They're
right.
0 to
It's
9.
only integers from 0 to 9, right? And a is also a digit. And basically, the units digit of b or the digit of b can only be 4 or 8 because or 0, I guess. Because these are the only integers between 0 and 9 that is the product of 4 and another integer that is between 0 and 9. So then if you look at these cases, if our units digit b is 8, then our tens digit would obviously have to be 2 because 2 times
Yeah.
4 is 8. And then, if we have 4, then it
Or
has to be
1.
1. Well, 0,
0,
then it would be 0, but
but it
that's not
has to be a
really a
positive integer,
two-digit
so
number.
it can't
But
be
also,
0.
if you add this, then it's
Yeah,
still
if it added,
0.
there's no, it doesn't add anything. So,
Right, but this isn't a two-digit integer anyway.
yeah.
Okay, so then these are our only possible two-digit integers.
Mhm.
So then we just add this. And then, we have just
40.
that's just 42.
Yep.
And then, yeah, we see that our answer is 42. So there we go. Okay, do you want to read for all of them, or how do you want this to
I can
work?
read it. A local restaurant boasts that they have 240 different dinner combinations. A dinner combination consists of an appetizer, entree, and dessert. If the restaurant offers 10 appetizer choices and 6 entree choices, how many different dessert choices does it have?
Okay, so, you know, if you have like 10 choices to something, then
Yes.
you're multiplying the total number of combinations by 10. And if you're multiplying, or if you have 6 choices for another something that is different, you're also going to be multiplying the total number of combinations by this number, which is 6. And we're trying to figure out what the combinations of of dessert is, which is also unrelated to either of these. So basically, like, the number of choices for all of these will multiply that number to the total number of combinations. So if we multiply all these numbers, then we should get our total number of combinations, which is 240. So then we just solve for x. So, 6 times 10 is 60. So we can divide 240 by 60. And then this is just 3. Whoops, this is 4. My bad. I can divide, yes.
Yeah, 240 divided by
Okay,
60 is 4.
yeah, and the answer is 4.
Yep. Okay, number 3. The enrollment at West Middle School is 450 students. If 300 students participate in sports, 125 students participate in fine arts, and 50 students participate in both sports and fine arts. How many students do not participate in either sports or fine arts? Okay,
Okay, one way you can do this is you can make a Venn diagram. Another way you can do this
you can
is
just kind of
just thinking
visualize it.
about it,
Yeah, just visualize it.
visualize it.
So if you have
Yeah.
300 students in sports, 125 in fine arts, if you're counting them, if you add 300 and 125, you'll be counting the students that are in both of them twice. So say you have say
Like what like yeah, so one thing you're trying to work towards to this problem is how many students are either in sports or in fine arts, right? Because that's the opposite of what we want. What we want is how many students do not participate in either sports or fine arts.
Mhm.
So, if it's the opposite of what we want, then we know that, the opposite and what we want, its sum is 450. So if we can get the opposite of what we want, then we can subtract that from 450 and we get what we want. So basically, we can also find the opposite of what we want, and it will eventually lead us to what we want. And the opposite of what we want is how many students participate in either sports or fine arts. Um, and then, like Bill was saying, one way you can find that is if you sum the people that participate in sports and you sum the people that participate in fine arts. But there are some people that participate in both sports and fine arts. And for those people, you're going to count them twice, right? Because they're going to be counted once in the sports category and they're going to be counted once in the fine arts category. But we only want to count each person once, right? So because we counted the people that participate in both sports and fine arts twice, but we only want to count them once, then we have to subtract the number of students that participate in both so that we only count them once because we would count them twice otherwise. So then the opposite of what we want is going to be 300 plus 125 minus 50, which is then going to be 425 minus 50, which is then going to be 375. Okay, and like I said, this is the opposite of what we want, right? If this is the number of students that participate in either sports or fine arts, then we could get the number of students that do not participate in either sports or fine arts by subtracting this from the total number of students, which is 450. So then we can do 450 minus 375, which is 75. And yeah, that is our answer. So that was just a way of thinking about it in your head. But I mean, I feel like for some people, it might be hard to just think of it in your head,
Mhm.
and get to it. So that's why I also have a Venn diagram way, and the Venn diagram way is very easy to follow. Um, like if you do the Venn diagram way, you can easily get to the answer. So basically, and then the Venn diagram way is a little bit slower. So basically, if you can, for these problems, if you can think of them in your head and the cases for it and stuff, then you can just do it that first way. But if you have a hard time doing that, or if you get questions wrong by doing that, then you could do the Venn diagram way. And let me show you what the Venn diagram way is. So I'm going to draw a box, and this is going to be my total number of students. This is going to be essentially the range of all of my students. And then I'm going to draw two circles, and each of these circles is going to represent a category of this problem. So one is going to represent sports, and one is going to represent fine arts. And then it says that 300 students participate in sports and 125 participate in fine arts. So basically, 300 students participating in sports, it's saying that this entire bubble will be 300. I'm thinking of the bubbles as values, and regional values is how many students fit into that region. So when it says 300 students participate in sports, then my whole sports bubble is going to be 300 students. Now, part of them is going to be in just sports, and part of them is going to be in both sports and fine arts. But, for the information that just 300 students participate in sports, that's just saying my whole bubble is 300. And then my fine arts bubble, it says 125 students participate in fine arts. So my fine arts bubble is going to be 125. And it says 50 students participate in both sports and fine arts. And the both sports and fine arts region is just going to be the overlapping of the sports and fine arts bubble. So it's just going to be 50 right here. So now you see we can solve for the regions that are only sports and only fine arts, right? Because we knew that this whole sports bubble was 300, and now we know that this region is 50. So then the only sports region, we know that is 250. And that's saying that there are 250 students that participate in only sports and not fine arts. And then We can also do this with the fine arts bubble. It said that 125 is in the whole fine arts, and 50 is in this region. So then this region must be 75. Okay, and then we want to know how many students do not participate in either sports or fine arts. So this would be the region outside of both the bubbles. It would be this border region right here, right? And we know that this whole box is 450, and we know that the two bubble region is just going to be 250 plus 50 plus 75. So then we can get this outside border region if we subtract this from 450. And then if you sum this, then you have 375, and then we again have 450 minus 375. And then we have 75 again, which is our answer. So yeah, this is like a different way to do it. It's like a way to visualize the problem, I guess. So if you rather like, if you like working problems visually, you can do this method, but it is slightly slower than if you just think of it in your head.
Yeah. I mean, when you think of it in your head, you're essentially just like, you're basically doing the same thing as the diagram.
Yeah,
You're
but
just
I mean, like
removing
some
drawing the
people might
diagram.
want to draw a diagram just to make it like solid, I guess.
Yeah.
Okay.
If you subtract 100 from the square of the integer n, the result is 50 more than 5 times the integer n. What is the greatest possible value of n? So you would just write an expression for n here. So n squared minus 100 equals 50 plus 5n. So this ends up just being like a parabola, and you're just looking for the highest point of it. Greatest possible value of n. Right? No.
So this is just a quadratic equation
Yeah,
in
it's a
n.
quadratic equation, and you're trying to solve.
So
You just solve it.
yeah. So we're gonna have two solutions to n in our quadratic
And we
equation, and
want
we
the
just want
higher
to
one.
find the greatest one.
Okay. It's
So you first look to factor it if possible.
yeah, and this is factorable. You can factor this.
Uh,
It will
with
be
what?
n minus
10 and
20
15?
n
Oh,
plus
okay.
15.
10 minus 15, or n minus 15 and n plus 10,
N
right?
minus 20 n plus 15. It's negative 5.
Wait, what?
It's n squared minus 5. Oh, wait, my bad. Oh, sorry, that's my bad.
Okay, no, that's fine.
I thought it was 300.
Okay. Yeah, so if we have n squared minus 5n minus 150 equals 0, we can factor this into n minus 15 times n plus 10, right? Because negative 15 times 10 is negative 150, and negative 15 plus 10 is negative 5. And if you can't do that, then you need to like review or like go through algebra
Yeah,
1. But yeah.
that's pretty.
Okay.
Yeah.
So if this equals 0, then we see our solutions of n, right? It's where either n minus 15 equals 0 or n plus 10 equals 0. So in this case, we're going to have n equals 15, and our other case is going to be n equals negative 10. And then if we just want the greatest possible value of n, it's just going to be 15. And yeah, that is the answer.
The student was supposed to substitute a certain value for x into the expression 2x cubed. The student thought the expression was 2x in parentheses cubed. If the student's answer was 384 greater than the correct answer, what value did the student use? So the student ended up with 8x cubed. So 384 will be just equal to 6x cubed.
Okay, or like you can say, the student's answer was 384 greater than the correct answer.
Yeah.
So like just by that wording, you're
Yeah.
saying the student's answer, which is 8x cubed,
Yeah.
is
Yeah.
384 greater. So you add that to
2x
then
cubed.
the correct answer.
2x
So
cubed.
and the correct answer was 2x cubed, right? And then this is just algebra and you solve it. So
Yeah.
6x cubed equals 384, and then you divide it by 6. It's going to be 64, and then the cube root of 64 is just going to be 4, or negative 4.
4? No, not negative 4.
No,
It's cubed.
not negative
It
4.
will be just 4.
Yeah, and it is just 4. Okay.
So, number 6, the amount of time it takes to shovel the snow in a parking lot is inversely proportional to the number of men shoveling. If it takes 3 hours for 5 men to complete the job, how many hours would it take 2 men to complete the job? Express your answer as the decimal to the nearest tenth. Okay. So, we can say like how fast, like, okay, how much work each man gets done per hour. Yeah.
Yeah.
So if it takes 3 hours for 5 men, each man would complete 1/15 of the work in an hour.
Yeah.
So if we have 2 men, it will be each of them, they will be doing 2/15 of the work per hour. And so for them to do the entire job, it will be 15 halves hours. So that's 7.5 hours.
Yeah.
Okay.
You can also do as like like it says the amount of time is inversely proportional to the men, right? So if you multiply the men by 2/5, because the time is inversely proportional, you're gonna multiply it by the reciprocal of this, which is 5/2. So you're gonna multiply the hours by 5/2, which is 5/2 times 3, which is 15/2. Also like what Bill said. So what Bill did was, he solved for the men, like how much work does a man do per hour? Um, so like you can solve for that, and then you can put it on the two men case, and you can find the hours for that. Or you can also just use the inverse proportionality stuff. Okay, so then if the hours is 15/2, then that's just 7.5 to the nearest 10. And yeah, we can see that is the correct answer.
The point 62 lies on a line with slope equal to 2/5. What is the distance between 62 and either one of the two closest points on the line with integer coordinates? Express your answer in the simplest radical form. Ooh, okay. So I don't think that like 62 actually matters. I don't think it actually matters like where the point is. You only have to look at
Sure.
the slope because like 62 is an integer coordinate. To go to the next integer coordinate, you just have to look at the slope, which is like the slope is basically saying that for every 5 units you go right, you go up 2, and like you can't really simplify that, right? You can't really get an integer coordinate between that.
Yeah.
So it's just going to be going to the right 5 and going up 2. So you're just looking for
Yeah.
that length. So it will be square
Yeah.
root of
And then
29.
that's just gonna be Pythagorean theorem,
Yeah,
which is square root of 29.
square root of
Um,
25 plus 4, 29.
like if you draw it out, essentially it's like, you're at the point 62, and it's on a line with slope of 2/5. So you're trying to find the shortest distance of this point to another point on the line, but the other point on the line has to have integer coordinates, right? If it didn't have integer coordinates, then you can have the other point be like infinitesimally small to the point 62. But so what if it had to be an integer? Well, if we have a slope 2/5, it means that every 5x that we go up 2. And these are integer pathways, right? So if we take the go right by 5 and the go up by 2, we're going to hit another integer point on the line. So right, this is another integer point on the line. But can we have any other integer point that is even closer to 62? Well, we can't, because you can think of this as a fraction, 2/5. It's already fully simplified, so there's no like smaller version of a run of 5 and a rise of 2 that we can take that still make some integers. But if the fraction was what simplifiable, then we can have a slightly smaller version of our rise and run. So if it was like 2 and 4, then we can simplify this to 1 and 2, and then our rise and run are still both integers, and then we will hit another integer point. But because like our fraction is already most simplified, then wherever it hits is going to be like the closest integer point. So then you just look at the triangle with a height of 2 and a base of 5. And this is a right triangle, obviously, because we're going in the x direction, we're going in the y direction. So then this distance is just going to be you could just solve that by Pythagorean theorem, which is then going to just be root of 29, and that is our answer. Okay.
On his sign test, Jason got 60% of the questions correct. He got 40 of the 60 multiple choice questions correct and 2/5 of the true-false questions correct. If Jason's science test consisted of only multiple choice and true-false questions, how many total questions were on the test? Okay.
Just like make some equations and stuff.
Yeah.
Yeah, so
We can say there were X true-false questions in total.
sure.
And then
If there are X if there are X true false total, Jason is gonna get 2/5 of them correct. So Jason is gonna get 2/5 X correct. He's also gonna get 40 multiple choice questions correct. So you can make like a correct table right there. And this is true false and this is multiple choice. And then we have another thing that says Jason got 60% of the questions. Questions is just saying like the total questions correct. So we also want to make an expression for the total number of questions. So total questions, we can put it here. And then, total questions for true false, we said that was X. And the multiple choice total was 60. So then our correct is going to be 40 plus 2/5 X, and our total questions is going to be X plus 60.
Right.
And it said Jason got 60% of the total questions correct. So this times 60% or 0.6 is going to equal how many he got correct.
Mm-hmm.
And then you just want to solve this. And also, 0.6 is just 3/5. So you can say that's 3/5 X. And then you're going to have 36. Yeah, 1/5 X is equal to 4. So then X is the total number of true false questions, and X is going to equal 20. And then we want to know how many total questions were on the test. So if there are 20 total true false questions and also 60 total multiple choice questions, then our total number of questions is just 80. And yeah, that is our answer.
Okay. Number 9. A pile of marbles has 15 to the 5th plus 3 marbles. It is to be divided into 7 piles with the same number of marbles in each pile. If there are X marbles left over, what is the value of X? Okay, so we have to look at modulus for this. So
yeah,
15.
So basically, right. So okay. So we have some number of marbles. We're putting it into piles. No. What? This would be divided into 7 piles with the same number of piles, the marbles in each pile. Okay. Like basically we're taking like 7 marbles out every time. Or you can think of it like that, you know. You can think of it as, you know, from our total number of marbles, we're taking out 7 marbles every time and we're putting 1 marble in each pile. And that works because, you know, we want the same number of marbles in each pile. So if we keep on doing that, then all of our piles will still have the same number of marbles. And then we want to know how many marbles are left over if we keep on taking them 7 at a time. Well, if you take something out of a number and like if you take a number out of a number and you keep on taking that number out and you want to know what the remainder is, there's a special function for that, and it's called modulus, right? You know, modulus is like you know, like in division, you're looking at how many sevens can I take out, but in modulus, you're looking at after I've taken out all of these sevens, how many marbles do I have remaining? Um, so yeah, that's just modulus. So basically, we're looking at our total number of marbles modulus 7. So we're looking at or this to the fifth. We're looking at 15 to the 5 plus 3 modulus 7. Um, and then you know x is just gonna be what this is, and
Yeah.
then um and then now you have to apply like you know
Properties
like
and stuff.
modular arithmetic, like modular properties and stuff, right? Like you know, like if
So
you try to like solve this normally, it's gonna be
yeah, 15
very
to the
hard,
5 is a
obviously.
big number.
Yeah, and you know you don't have a calculator on this on Sprint, so you're gonna want to apply modular properties to make it better. And you know, like one modular property is that we can substitute 15 with like we can substitute base powers of stuff with what it is modulus what we are looking at. So we
Yeah.
can substitute
We can
15.
substitute two numbers as long as they have the same modulus, basically.
Well, I mean, we can't substitute like powers like that, right?
Okay.
Like if we had to the power of
Yeah.
15, we
Yeah.
can't substitute 15 with like 1, right? So but like any base number, you know, you have a base number to a power or just like a number on its own. You can substitute it with what it is in whatever modulus you're looking at. And so we can substitute 15 with modulus whatever it is in 7. Like we can substitute it for whatever. And you know, we probably want to make this as small as possible because you know if we make it small enough, like it's 1, 2, or 3, then we can actually just actually like solve for what it is to the 5th power and add it and then solve in mod 7. So if we look at what this is in the smallest version of itself in mod 7, it's going to be equal to 1 mod 7, right? Because 14 is a multiple of 7. So 15 mod 7 is going to be 1 mod 7. And then so that means we can substitute 15 with 1. And this is very good, right? Because, you know, 1 is a very small number and we can solve for 1 to the 5th very easily. So then our expression becomes 1 to the 5th mod 1 to the 5th plus 3 mod 7. And then this is going to be 1 plus 3 mod 7, and this is 4 mod 7. And then so this is going to be our answer, right? And it also says like, you know, x has to be between 0 and 7. That's basically just saying it wants your least mod. And we can see that is our answer. Okay.
A a ROTCAF is a number that results from adding a number and the greatest factor of the number that is less than the number. For example, the ROTCAF of 9 is 9 plus 3 or 12. What is the sum of the ROTCAFs of all the even numbers between 1 and 25? Okay, so all the even numbers between 1 and 25. The raw cast for those would just be like half of them,
It
correct?
plus
It plus
half of
half of itself.
itself.
So we can just add up all the even
Right.
numbers
Like,
between 1 and
yeah,
25 and then multiply that by 1.5.
yeah, like if you think of an even number, um, the greatest factor of the number that is less than the number has to be half of the number, right? Like um the greatest factor it can have will have to be um you know it has to be paired with the smallest factor the number can have, right? Well, that is not one, or else the factor would be itself. um and in an even number we know that it has a factor of two, and two is like the least factor that an integer can have that is greater than one. So then we know that its greatest factor in the number that is less than the number has to be half itself. Okay. So then then we can sum all the even numbers between 1 and 25, and also sum all the even numbers halved between 1 and 25. So that's going to be 2 plus 4 plus dot 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 all the way to 24. And then we're also going to have to sum half of all these, which is just going to be 1 plus 2 plus dot 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 all the way to plus 12. And then this is just like arithmetic series. You have formulas for this. It's just going to be the mean of the sequence, or yeah, it's just going to be the mean of the sequence times the number of numbers that are in the sequence. And you can find the mean of the sequence by taking the mean of the first and last numbers. So the mean of the first and last numbers is going to be 26 over 2, which is 13. And then you multiply by the number of numbers, which is just going to be 24 over 2, right? Because you can count this. You can count the places of these numbers by dividing it by 2. So 2 is in the first place, 4 is in the second place. So 24 is going to be in the 12th place. That means there are 12 numbers in total. So this is the sum of that. And then just doing the same thing again, we're gonna have this. So then and this is also gonna be half of the sum of this one. So if you also don't want to go through the formula again, you can just calculate half this one. And then 13 times 12 is just gonna be what one or it can be 144 plus 12, which is 156. And then this is just going to be 156 over 2, which is 78. And then you add it together, and then you have 234. And yeah, that is our answer.
Okay. Miss Marks is selecting students for a committee that must consist of 3 seniors and 5 juniors. 6 senior volunteers are able to serve on the committee. What is the least number of junior volunteers needed if Miss Marks wants at least 100 different possible ways to pick the committee?
Okay. So 6 senior volunteers are able to serve on the committee, and the committee must consist of 3 seniors. So then that's just we're picking 3 seniors out of 6. There's like a special function for that. That's the choose function, right? So the number of ways to arrange our seniors is just going to be 6 choose 3, which is just going to be 6 times 5 times 4 over 3 factorial. 3 factorial is just 6, so cancel that out. That's just going to be 20. So just choosing our seniors, we have 20 ways to choose our seniors, and the number of ways to pick the whole committee is going to be the number of ways we can choose our seniors times the number of ways we can choose our juniors, and that's going to be the total number of ways you can pick the whole committee, right? And let's just say X is the number of ways we can pick our juniors. So then we're saying 20 times X has to be greater than or equal to 100, or X is greater than or equal to 20. Okay. Or no, not 20, sorry. It's going to be greater than or equal to 100 over 20, which is 5. And then, so how are you going to have it so that, something choose 5 is at least 5 or more. Well, if we do the least, which is 5 choose 5, this is 1, which is not big enough. And if we go 1 up, which is 6 choose 5, then this is 6. And this 6 is just enough. So that means this is going to be our the case that we work with, and then that means we're gonna choose from 6 juniors. So that means our answer is going to be 6, and yeah, that is the answer.
Okay. Number 12. Elmo is making 3-letter words using alphabet blocks. Each of the 3 blocks has a different letter on each of the 3 faces, and pictures on the remaining 3 faces. How many 3-letter words can Elmo form if none of the blocks have any letters in common?
Okay, so we're looking at how many 3-letter words can be formed, and we have 3 blocks. Each of them have 3 different letters from itself and the other blocks, and we want to form words, and words are basically just like 3 letters that are together. So if we just think of the 3 cubes having the their own 3 letters, if they are all stuck in their positions, then the number of words we could make is just going to be 3 cubed, because each of the blocks, if they're in the same position, each of the blocks you can have 3 possible ways, like 3 possible letters you can choose from. So then it's just going to be 3 times 3 times 3. But you can also rearrange the blocks in any order, and you're going to have different words, right? Because all the blocks have different letters. So you're also going to have to multiply this by the number of ways you can arrange the blocks, right? Every arrangement of the 3 blocks that you have is going to also be another 3 cubed. So we're going to multiply this by the number of ways you can arrange the 3 blocks, which is going to be 3 factorial, or 6. So then we have 27 times 6, which is then 120 plus 42, which is 162. That is our answer.
Okay. 13. The function f is defined by f of n equals f of n plus 1 plus f of n plus 2, with f of 1 equals 0, f of 3 equals 4. What is the value of f4? Okay, so this is kind of just like
Okay.
the opposite of Fibonacci. You can just find
Yeah.
you can find the value of f of 2. You know f of 1 is 0, f of 3 is 4. So f2 would have to be negative 4.
Yeah. So that -4 plus 4 is 0. And then with f of 2 and f of 3, you can find f4, right? You can say f of 2 is f of 3 plus f of 4, and we just said f of 2 is -4, f of 3 is 4, so then f of 4 is going to be -8. And that is our answer.
Number 14. In the sequence 8, 25, 76, 229, each term after the first term is b more than 8 times the preceding term. What is the value of a plus b?
Okay. So you can just set up like system of equations for this, right? Like it's saying you can look at a and 25, and it's going to be saying what? It's going to be 8 times the preceding term, and you add b. So 8 times a plus b is going to equal 25. And you can also say that for 25. You can say 25a plus b is going to equal the next term, which is 76. And then, this is just a system of equations. And, solving this, we're going to have 17a equals 76 minus 25, which is 51. And then a is just going to equal 3. And that means, we can just look at any of these. If a is 3, then a times 3 is 24. So then b has to equal 1. So then we just have a equals 3, b equals 1, which is, which, 3 plus 1 is 4. That is our answer. You can solve this algebraically, it's very easy, or I can also just kind of assume that a and b are going to be integers, and you try to look at it, and you can see that every term about like triples. And then if you go with that, then you can see that every term is going to be tripled, and then you add 1 to it. So then, but I mean, just solving it algebraically is also very quick.
Yeah. Okay, number 15. 7 numbers form an arithmetic sequence. The median of the 7 numbers is 5. The mean of the 4 largest numbers is 7 more than the mean of the 3 smallest numbers. What is the ratio of the smallest number to the largest number?
Well, and express your answer as common fraction. Okay, so we have 7 numbers, and they're an arithmetic sequence, and we know the median, or the middle of the 7 numbers, is 5. So the middle is going to be 5, and we're going to have 3 numbers on either side of the 5. One way we can do this is we can call the difference between each of the numbers, which is going to be the same, right? Because we have an arithmetic sequence, we can call that d. So then we have 5 and 5 plus d, and 5 plus 2d, and 5 plus 3d on the increasing side of our 5. And then on the lower side of 5, we have 5 minus d all the way to 5 minus 3d, right? And then it says that the mean of the 4 largest numbers, which are these numbers, is 7 more than the mean of the 3 smallest numbers, which are these numbers. So, we can try to set up an equation for that, and then solve for d, and then solve for what we want. So, to take the mean of 4 numbers, we add them all up and divide by 4. So we add all of this up, we're going to have 20 plus 60, and we're going to put it over 4, and then, so this is the mean of the 4 largest numbers, and then our 3 largest numbers, or our 3 smallest numbers, its sum is going to be 15 minus 60, and its mean is going to be this over 3. And then what it says that the mean of the 4 largest numbers, this is 7 more than the mean of the 3 smallest numbers. So then this is going to be our equation, and then what we can do is we can divide 15 over 3, and then we have 5, and then we can divide that. So then we have 5 minus 2d plus 7 is, we could divide 20 by 4, so that's 5, and then we add 3 halves d. We can cancel out the 5s on both sides, and then we can add 2d onto this side, so then we have 7 equals 7 halves d. So then d is going to equal 2. If d equals 2, then our largest number, 5 plus 3d, is going to be 5 plus 6, or 11. Our smallest number, 5 minus 3d, is going to be 5 minus 6, or negative 1. Then the ratio of our smallest number to our largest number is going to be negative 1 over 11. And that's already simplified. And yeah, that is our answer.
Yep. Okay. Number 16. The surface area of a rectangular prism is 32 square inches. The volume of the prism is 12 cubic inches. The sum of all edge length is 28 inches. If the length, width, and height of the prism each are increased by 1 inch, what is the volume of the resulting prism in cubic inches?
You want to talk about this one?
Yeah, okay. So like, from the information given, you find the surface area of a rectangular prism by, like, say, if we say that the side length are x, y, and z, the surface area can be represented by 2 times x times y plus, yeah, what Austin is writing, 2 times y plus z times plus 2 times x plus z. The volume is x times y times z. And then the sum of all edge length is 4 times x plus y plus z.
Yeah, and you can get these formulas just by thinking of the cube, right? Or I mean the rectangular prism. Like obviously volume is x, y, z. Surface area, that's just area of the faces, and 2 of every type of face. And you have 12 edges in total and 4 of each edge.
Okay, so now, so from this we can figure out what x, y, z, x, xy plus yz plus xz, and x plus y plus z is. So now we now we want to try to use these to like find.
Wait, Bill.
Yeah.
I think you put the stream in touch your category.
Oh, I thought I changed it.
Did you change it?
I changed it. Did it not go
You
through?
did. Oh, I think you did change it.
Okay.
Okay. Okay, yeah, I can keep going.
Okay. So yeah. So now we want to use these to we want to combine these into an expression. So if we actually look, it's asking the question itself is asking for if the length, width, and height of the prism each are increased by 1 inch, what is the volume of the resulting prism? So what that is, it's basically x plus 1 times y plus 1 times z plus 1.
Yeah.
And then so if you expand that, you end up with x plus y. No, sorry, xyz. I meant xyz. xyz plus xy plus yz plus xz plus x plus y plus z plus 1. And if you look at that, we actually have the values for every single one of them. xyz is equal to 12. xy plus yz plus xz is equal to the surface area divided by 2, which is 16, and the edge length, and x plus y plus z is equal to the edge length divided by 4. And so that's 7. So now we add those and then we plus 1, and that's our answer.
Yeah, 12 plus 16 plus 7 plus 1. That's just gonna be 36. Yeah, that is our answer. So yeah, so this was a very clever way to do it. Like, seeing that what we wanted, which is this can be expressed as terms that like we can derive from. If you can't find this way, you can solve it like normally, which is having 3 systems of equations. Like if you look at this box, um, this is 3 system of equations with 3 variables, right? So you could solve for the variables like that. But it's going to be like a little bit slower, right? You're solving 3 system equations. So if you can find the clever way, then you save a bit of time. But also, if you can, you can just solve it normally with solving the 3 system of equations. Okay.
Okay, number 17. A square has sides of length 4 units each. A strip of width 1 unit is drawn inside the square. Center on the diagonal. The area of the strip can be expressed in the form a plus b squared of 2 units,
It's
where
a
a and b are
stripe.
rational numbers. What is the value of a plus b? Express your answer as a decimal to the nearest tenth.
It's stripe, not strip. Okay. Okay. Yeah, we have a stripe in a square. We want to find the area of the stripe. And we know that its width is going to be 1. So you can do this multiple ways. You can find the area of the dark triangles and you subtract it from the total area of the square. You can also try making the stripe into like some shapes and stuff, and you can find the area of those and you add them up. Um, I guess I would just do find the areas of the triangles, add them up, and subtract them from the total square. And how are you going to find the side lengths of the triangles, right? That's what you need to find the areas. Well, we know the whole length of the square, so if we can find this small edge right here, we can find what the side length of the triangle is, right? So if I just draw this, boom, and then boom, that's a little bit bad. Boom. We can find what this is if we find what this is because we know that the whole thing is going to be 4. And how can we find what this is? Well, if we look at this, this is a width of 1. We can bring this width down right here. This is still going to be a width of 1. And this is going to make a 45, 45, 90 right triangle, right? Because, because this has to be a 90-degree angle and our strip is symmetrical about the square. So then because it's 45, 45, 90, then what this edge is going to be 1 over root 2. And if you rationalize 1 over root 2, then you have root 2 over 2. And then what the edge of the triangle is going to be, is going to be 4 minus root 2 over 2. So then the area of one of these triangles is going to be 4 minus root 2 over 2 squared over 2. And then, both the triangles is just going to be this times 2. So getting rid of the over 2. And then we just need to subtract this from 4 to get what the area of the strip is. So then this is 4 minus 16. And then we have minus root 2 over 2 times 4 times 2, which is 4 root 2. And then we square minus root 2 over 2, so then that's plus 1/2. And then we have what? Negative 12 plus 1/2 minus 4 over root, or 4 times root 2. Wait, did I do this correctly?
Let's see.
4 minus root 2 over 2 squared? Oh, it should be minus 16. The area of the square is 16.
Yeah, 16.
Okay. So then these 16s cancel out. Then we have negative 1/2 plus 4 root 2. Okay, and then if we look at our expression format thing, a will equal negative 1/2, b will equal 4. And then the sum is just going to be, a halves minus 1/2 is going to be 7/2. Or, oh, okay, to the nearest tenth. So this is going to be 3.5. My handwriting is very bad. Okay. It's going to be, see, my 5s look like a 6. 7 halves is equal to 3.5. And that is our answer.
Number 18. The median k of a set 5 numbers is 3 times the mean of the 5 numbers. If the median is removed from the set, the mean of the remaining 4 numbers is what fraction of k? Express your answer as a common fraction. Okay.
Yeah.
So
Okay.
we can express the sum of all the numbers with k, right? So the mean of these 5 numbers is 1/3 k. So the sum of all these numbers will be 5/3 k. So the mean of all these numbers is 5/3 k. If we remove k, then we will be left with 2/3 k.
As the sum.
Us the sum. 2/3 k us the sum. And now there are 4 numbers. So we just divide that by 4. 2/3 divided by 4. We're left with 1/6 of k.
Yeah. Or I mean, yeah, and their answer would be 1/6. I mean, k over 6 is technically wrong, right? It says like is what fraction of k.
Yeah, what fraction k? So k over 6 is wrong.
Yeah, I probably like the teacher we got this from. But I don't know. 1 over 6 is more correct.
Number 19. What is the probability that a list of 5 different single-digit numbers whose sum is 31 will contain exactly 2 prime numbers? Express your answer as a common fraction.
Alright, this one we thought was a little bit weird. So you have a list of 5 different single-digit numbers, and you need to sum it to 31, and you want to know what's the probability that the list has 2 prime numbers. We thought this was kind of weird because like there's not really like any relation for like listing 5 different single-digit numbers so that the sum is 31. And like especially looking at the probability that they have 2 prime numbers. So because like like it's so unrelated and you can't really have like any equations describing it, you pretty much just have to list out your lists and look at your probability that way, which is just going to be the number that satisfies your condition over the total number of lists that you have. So let's think about our possible lists. So let's think about the biggest list that we can have, or like the biggest 5 number sequence that we can have that are different, right? Which is going to be 5, 6, 7, 8, 9. Let's look at the sum. This is going to be what? This is going to be 20. This is going to be 35. Sorry. Okay, so because this sum is 35 and we want our sum to be 31, then we need to subtract 4 from all of these numbers in total. So, when we can do that, so we can have 4, 5, 6, 7, and then 9. Okay, and now we want to make our other lists that also have 5 different single-digit numbers, but it still sums to 31. So what we can think of doing here in our list is like raising an integer by 1 and decreasing another integer by 1. But you have to remember that we have to have our digits all be different. So we can see that we're missing a digit of 8, so we can get a digit to be 8. So one way we can get a digit to be 8 is subtracting 1 from 9, right? If we subtract 1 from 9, then we have to add 1 to another integer, 4, 5, 6, or 7. But if we add 1 to 4, 5, 6, or 7, they're gonna clash with another number. So that's not gonna work. Another way we can get an 8 is if we add 1 to 7, right? Then we need to decrease another number by 1. Well, if we decrease 9 by 1 and we're gonna get an 8, then that's not gonna work. We're gonna have 2 8s. And we can't decrease 6 or 5, they're gonna clash with their lower neighbor. So, but we can decrease 4. So then we can do it that way. So then we can have 3, 5, 6, 8, 9. And then here you can see we're missing a 7. So and we can get a 7 either by, decreasing 8 or raising 6. If we decrease 8, then we need to raise another digit. We can't raise 9 because then it would be not a digit. We can't raise 6 or 5 because they would clash with their upper neighbor. But we can raise 3. But if we raise 3, then we're just gonna have 4, 5, 6, 7, 9 again, and we already have that case. So what about what if we raise 6 to 7? Well, then we need to subtract 1 to a number. Well, 8 and 9 isn't gonna work because we're gonna have 7, 8, 9. But we can subtract 1 from 3, or 1 from 5. Sorry. So we have 3, 4, 7, 8, 9. But you see, we can also subtract 1 from 3, so that's another case. So 2, 5, 6, or 2, 5, 7, 8, 9. And then now we need to look at these. 3, 4, 79. We can raise the 4. Oh, wait. Wait, give me 1 second. My computer's about to run out of battery.
Okay.
I need to get its charger. Okay. So looking at 3, 4, 7, 8, 9, we can decrease 3 and raise 4, but that we already have that case. From this, we can raise 5 and decrease 2. Then we have 1, 6, 7, 8, 9. And then we can't really do anything else. We can't decrease 1 anymore. If we like decrease 6, then all we can raise is 1, and that's just gonna give the case that we had before. And so you're just gonna have to think that through. This is all the 5 cases that I can have, and then so then once you have that, then you just count how many have exactly 2 prime numbers, and you put that over the total number of lists, which is 5. So how many have 2 prime numbers? Well, this one has 5 and 7, so that's 1. This one has 5 and 3, so that's 2. This one has 3, 7, so that's 3. This one has 2, 5, 7, so that doesn't work. And this one has only 7, so that doesn't work. So then we have 3 out of 5, our probability is 3/5. So I don't know. This one took kind of long because I had to talk through everything. But like if you're finding the list of this like in your head, you should like just go through it faster. Right? Okay.
Okay, number 20. If x halves plus y thirds equals 1 and x fourths plus 2y thirds equals -1, what is the value of the sum of x and y? So this is just like a system of equations that you can just solve.
Yeah.
So this is pretty straightforward.
Yeah. I mean, I don't know. Do you even know how to solve it? I mean, like, yeah, okay, sure. I guess I'll solve it.
Oh,
What?
I mean, how else would you do it?
No, I mean, like, do we really like wouldn't everyone watching us know how to solve a system of 2
That's
equations?
true. But you literally explained what you had to explain what modulus was earlier. So like,
No. I mean, I feel like some people might not know modulus.
okay, fine.
I mean, like, they don't teach that in school, but system of 2 equations. This is just algebra 1. But yeah, so you can have 3x plus 2y over 6 is 1, so that's 3x plus 2y is going to equal 6. And then we can also have 3x plus 8y over 12 is going to equal -1. So then 3x plus 8y is going to equal -12. And then, we can just, let's subtract this one from that one. So then we have -6y equals 18, so y equals -3. And then, like, looking at this one, then we're going to have 3x equals 12. So then x is going to equal 4. So then, sorry, that's a negative. Then the sum of x and y is just going to be 4 minus 3, which is 1. And that is our answer.
Okay. 21. Bob and Tom each roll 2 standard 6-sided die. What is the probability that the product of their individual sums is greater than 100? Express your answer as a common fraction.
Okay. You need to think of the ways that you can have, the sum of 2 6-sided dice, and you have those sums product to something greater than 100. So, think of what the sums of 2 6-sided die can be. It can range from 2 to 12. So, if we're looking for greater than 100, we can see that, if we have 2 sums of 12 and 12, that's going to work. It's going to be 144. If we have 12 and 11, this is also going to work. That's going to be 132. And then going down to 10, oh, well, we can also have 11 and 11. And, now let's look at 10. So 10, 10 we can have 12 and 10, we can also have 11 and 10. But we can't have 10 and 10 because it has to be greater than 100 and not exactly 100. And then can we have anything else? Can we have a 9 perhaps? Well, we can have a 9. 9 and 12 makes 108, which is greater than 100. But 11 and 9, that's going to be 99, so that's not going to work. And then you can try 8, so 12 and 8, but this is going to be 96, which is also not big enough. So then we can see this is going to be all of our cases. So now we want to know, what's the probability of each of these cases? And we have to add all those probabilities together. Well, you have to think of the probabilities of each of the sums of these dice. Now, there's a thing I have where you look at the probabilities of the sum of two dice. So basically, if you're looking at a sum of 7, the value for this is going to be 6. And as you go outwards from 7, if you're looking at 6, 5, 4, or 8, 9, 10, you see these are going to have values subtracting a 1 away from 7. So 5, and then 4, and then 3. And then at the very end, which is going to be 2 and 12, these are going to have 1. And let me just fill out the whole thing, I guess, because I'm already there. So basically, the probability of one of these sums is going to be this number over 36. So the probability of rolling a 7 with 2 6-sided die is going to be 6 over 36, or 1/6. The probability of rolling a 12 is going to be 1 out of 36. So we can see the probability of rolling 12 and 12 is going to be 1 out of 36 times 1 out of 36, or 1 over 6 to the 4th. So we can put that as the probability for getting 12 and 12. What's the probability for getting 12 and 11? Well, 12 is going to be 1 out of 36. 11 is going to be 2 out of 36. The probability of getting 2 and 11, or 12 and 11, is going to be 2 out of 6 to the 4. But you have to be careful because this can be arranged in another way, right? You can get 12 and 11, or you can get 11 and then 12. So because there are two cases that you can get 12 and 11, then you have to double like its normal probability. So then it's going to be 4 over 6 to the 4. And then you basically just do this with all of them, right? So 11 and 11, that's going to be 236 times 236, which is going to be 4 over 6 to the 4. And because it's double 11s, you can't you can't arrange that in any other way. So it's just going to be 4 over 6 to the 4. 12 and 10, that's going to be 1 times 3, which is 3 and then over 6 to the 4. And you can arrange this in two ways. So then you're going to have to double that. So you're going to have 6 over 6 to the 4. Oops. 11 and 10, that's going to be 2 and 3. So that's going to be 6. And you can also arrange that in two ways. So then you're going to have 12 over 6 to the 4. 12 and 9, you're going to have 4 and 1. So that's going to be 4 over 6 to the 4. But you can also arrange that in two ways. So you have 8 over 6 to the 4. Now you add this all up. And I'm just going to add all of the tops first. And it's going to be all over 6 to the 4. So I'm going to have 5, 9, 15 plus 20, which is 35. So I'm going to have 35 over 6 to the 4. So obviously 35 doesn't have, any factors of 2 or 3. So this is not simplifiable. So what is 6 to the 4? Well, if you don't know that, you can just multiply 36 and 36. If you do know that, then, it's just 1296. That means then our fraction is 35 over 1296. And that is our answer. And all right, it is 7:59, so we're gonna stop here. So next week, you'll continue on 2011 sprint. And yeah, that's it for this meeting. So if you ever have any questions for us, you can let us know, and that's gonna be it. Thank you for watching and goodbye.